Okay, so we have a couple of things to talk about today. The first is being able to look at a general equation and determining what kind of conic it is. Now, we've been talking about this in every single section, okay? Now we actually get to put them all together and determine which is which. Okay, so that's the first thing I want to look at. Number one here, look at the equation. What is it? Ellipse. Sarah, you were first. How do you know it is an ellipse? Okay, we have an x squared and a y squared, and they're both positive. So we know that has to be an ellipse. Okay? How about number two? Parabola, general y. Okay, we have y squared, but not an x squared. Will this be opening horizontally or vertically? Horizontally, it's going to open either left or right. Okay. Number three. I heard ellipse, and then I also heard circle. Which one? You're right, the x squared and y squared are both present, and they're both positive. But what's true about their coefficients? They're the same, which is going to make it a circle. Okay. And finally, number four. Why?
Because both x and y are squared, but they look different. And one is one's negative.
Okay, x squared and y squared are both there, but one's positive, one's negative, so it's a hyperbola. Okay? So that will be a part of your homework assignment today. Okay? Now, let's talk about working backwards from hyperbolas. Okay? Here again, what am I going to make you do with the information? Okay? Draw some sort of a picture to help. Okay? So we have vertices at 4, 0 and negative 4, 0. And we have foci at 6, 0 and negative 6, 0. There's a few different things we can pick out from this. What's one? Okay, our center is going to be at 0, 0. What else? Okay, this is going to be a horizontal hyperbola, which means the x minus h squared has to be positive, and the y minus k squared is the one that's being subtracted. Remember, the a squared always comes with a positive variable. All right? Next thing we can determine from our picture. How far away are our vertices? 4. What does that give you? That gives you A. How far away are our foci? And what does that give you? That gives you C. So now what do we need to do? Find B. And how do we find B? Good. So C squared would be 36. A squared would be 16, which means B squared is 20. Here again, since B squared is what's in our equation, we don't have to solve for B, we just can stop at B squared. All right? So we have A squared, we have B squared, we have our center. So x minus h squared and y minus k squared would look like that. What goes underneath x squared? And underneath y squared? Don't forget equals 1. Any questions? These are going to be very similar to the ones we did with ellipses, aren't they? Not the same, but similar. Okay, let's talk for a minute. A is going to be how far away our vertices are from the center. C is how far away our foci are from the center. What else do we know about B? What is something else that we can know about our hyperbola that could help us with B? Okay. If we know our asymptotes, if we know the slope could help us with A and or B. Okay? Because the slope of our asymptotes will always be either B over A or A over B, depending on what direction our hyperbola is. Okay? Here's one that is similar to, what was it, like number 41 from yesterday that we asked about. We have a hyperbola with vertices, -2, 1, and 2, 1, and it passes through the point 5, 4. What direction is this hyperbola? Horizontal. Which means we're going to have x minus a squared over a squared minus y minus k squared over b squared equals 1. Okay. What do we know from this picture? Center is at 0, 1. Do you agree? Yes? Okay. What else? One more thing that you can tell me. A is 2 because our vertices are 2 away from the center. Okay. Right now, can we tell anything else? Can we identify C or B? Do we know our asymptotes? Okay, so what I'm going to do is I'm going to go ahead and put this information in. X minus a squared over a squared minus y minus k squared over b squared that we don't know equals 1. We do know a point on our hyperbola. Can we use that? What can we do with it? Plug it in so we can solve for b squared. So our point is 5, 4. So I'm going to have 5 squared over 4 minus 4 minus 1 squared over b squared equals 1. Alright? So we have 25 fourths minus 9 over b squared equals 1. What do we do now? Okay, we need to subtract 25 fourths over. So what is 1 minus 25 fourths? It would be negative, correct? Negative 21 24ths. Okay. We now have a proportion. We can cross multiply. 21b squared would equal why did I say 24? 21 fourths, thank you. I don't even know where that came from. Okay, now let's cross multiply. Is everyone okay now? Thank you for speaking up. We have 21b squared equals 36. the negatives end up canceling each other out, right? And so b squared is 36/21, right? Okay, so now we can come back to this standard form, and we can write x squared over 4 minus y minus 1 squared over our b squared is 36/21. You can write it like this, or if this bothers you because there's a fraction in your denominator, you can go ahead and multiply by the reciprocal. Write it like this. I want to know how I got from here to here. Questions on this one? Okay, last one. Okay, we have vertices at 3, 0, and 3, 4. Okay, what do we know from that? Okay, let's talk about our center before we identify A. Where would our center be first? Okay, so our center would be 3, 2. And so now, Joey, what is A? Okay. What else do we know? It is vertical. So we're going to have y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay, now we have our two asymptotes. Y equals 2/3 x.
Were we given a different equation for again?
What?
Were we given a different equation for again?
Yes, but these, what form are these in right now? They're in slope-intercept form. They're easier to graph that way. Okay. But we can easily see that both of them are going through the center, right? Okay. I still want you to do the point slope form. Okay. Okay. So what do we know about B? Okay, Jenna, talk us through how you got B to be 3. Okay, our slope is always going to be either A over B or B over A. So if we're looking at this hyperbola that's opening vertically, we know that we moved A vertically to plot those points, and we know that we're going to have to plot those B values horizontally. So since we moved A vertically, that's our rise, and B is our run in this example. Okay, so since our slope is 2/3, and we know A is 2, then B has to be the 3 in our slope. Okay, so what we can write is y minus 2 squared over 4 minus x minus 3 squared over 9 equals 1. Remember that a squared always has to come first. It does not matter if it's bigger or smaller.
Go over how you got B again.
Yes. Okay, our slope of our asymptotes we find by rise over run. And since we formed that rectangle with A and B, it will either be A over B or B over A. Okay? Now, our vertices are vertical, and that's our A value. Okay, so our rise from center to vertex is 2. All right? Which matches this number right here. So our rise over run is 3. So to get to the corner of that frame, we went over 3. That's our B value. Do I need to explain that one more time? Okay, so this is what I want to do. Go ahead and write down your homework.